Hello everyone. This video is in continuation with the previous video, Is Matter Around Us Pure? Solutions and their concentration. If you haven't seen that video, please do check that as well, and if you like our videos, then please give a thumbs up and subscribe to our channel. In our previous video, we discussed various formulas to determine the concentration of the solution. Here we have one example. A solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. This was one of the formulas we discussed. Mass of the solute is 40 grams. Mass of the solvent is 320 grams. Obviously, salt here is the solute and water here is the solvent. Now we know that mass of the solution is equals to mass of the solute plus mass of the solvent. Adding both these quantities, we get 360 gram of mass of solution. Now calculating the mass percentage of the solution. As we discussed the formula, mass percentage of solution equals mass of solute upon mass of solution into 100. Therefore, we have 40 upon 360 into 100, which gives us 11.1%. In our first lecture, while dealing with one of the activity in which certain substances were mixed with water and solutions, suspension and colloidals were obtained. Well, now we shall be discussing what is a suspension. Non-homogeneous systems like those obtained previously in which solids are dispersed, that is, they are distributed or scattered in liquids, are called suspensions. Suspension is a heterogeneous mixture in which solute particles do not dissolve. They remain suspended throughout the bulk of the medium and particles are visible to the naked eye. In the activity performed earlier, when chalk powder or wheat flour was mixed with water, we obtained a suspension. Let us now discuss various properties of suspension. Suspension is a heterogeneous mixture. Particles of the suspension are visible to the naked eye. Particles of a beam of light passing through them make its path visible. Particles in a suspension scatter the beam of light, as a result of which the path is visible. The solute particles scatter down when suspension is undisturbed. If a suspension is left at rest and is not disturbed, all the solute particles settle at the bottom. That is, a suspension is unstable. Further, particles can be separated from mixture by the process of filtration. And when the particles settle down, suspension breaks and does not scatter light anymore. Due to the settling down of particles to the bottom of the vessel, the scattering of light doesn't happen anymore, as a result of which path of light is not visible. Now we shall be discussing what are colloidal solutions. Remember in the activity discussed the group D, which was obtained by adding few drops of ink or milk to water, was a colloid. The particles of colloid are uniformly spread throughout the solution. This can be observed in our homes as well. If we try to drop few drops of milk in a vessel containing water, we obtain a uniform spread throughout the vessel. Due to the relatively smaller size of particles as compared to suspension, causes the mixture to appear homogeneous. As the size of particles is small as compared to that in suspension, our mixture appears homogeneous, but it is actually heterogeneous in nature. Due to the small size of colloidal particles, we cannot see them with naked eyes, as opposed to particles in suspensions which are clearly visible through naked eyes. But these particles can easily scatter a beam of visible light. The scattering of a beam of light is called Tyndall effect and is named after the name of the scientist Tyndall. Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. Often we might have observed in our homes that if a door has a small keyhole, then we can observe a fine beam of light entering our rooms. This happens due to scattering of light by the particles of dust and smoke in the air. The air around us is full of particles of dust. These dust particles scatter the incoming light, as a result of which we can see a fine beam of light. Given below is an example where a torch is held in front of two vessels. The first vessel contains the solution of copper sulfate, and the second vessel contains the mixture of water and milk. We can see that light is not scattered in solution A, but the path of light can be easily seen in case of vessel B, which contains the mixture of milk and water. Tyndall effect can be observed when sunlight passes through the canopy of a dense forest. How come this happens? Well, in forest, mist contains tiny droplets of water, which act as particles of colloids dispersed in air. Therefore, they scatter the beam of light, as a result of which Tyndall effect can be observed. Let us now discuss some properties of a colloid. Colloid is a heterogeneous mixture. The size of the particles of colloid is too small to be individually seen by the naked eyes. The size of the particles in case of colloid is not as big as in case of suspensions. Therefore, particles cannot be seen through naked eyes. But colloids are big enough to scatter a beam of light passing through it and make its path visible. Like we discussed in the case of an example of Tyndall effect, when the two vessels, one containing the solution of copper sulfate and other containing the mixture of milk and water, were kept in front of a torch, then the path of light was visible in case of the mixture containing water and milk, which forms a colloid. They do not settle down when left undistributed, that is, a colloid is quite stable, as opposed to the case in suspension, which when left undisturbed, the particles settle down. They cannot be separated from the mixture by the process of filtration, but a special technique of separation known as centrifugation can be used to separate the particles. As in case of suspensions, we discussed that particles can be separated by the process of filtration, but colloidal solutions require the process of centrifugation for separation of its constituent particles. The components of a colloidal solution are dispersed phase and dispersion medium. The solute-like component or the dispersed particles in a colloid form the dispersed phase, and the component in which dispersed phase is suspended is known as the dispersing medium. Pretty much as is the case with the solute and the solvent. Colloids are classified according to state of the dispersing medium and the dispersed phase. We shall be discussing examples related to this in our next video. In our today's video, we discussed an example in which we calculated the concentration in terms of mass by mass percentage of the solution. We discussed what is suspension, what are various properties of suspension. We also discussed what are colloidal solutions, what is the Tyndall effect, and various different properties of a colloid. That's it for today's video. If you like our videos, then please give a thumbs up and subscribe to our channel. Thank you.